All right, so here's a quick correction on yesterday's follow-up exit ticket using data analysis, but this time using a dot plot, mean, and MAD rather than the box plots we've been using this week. So starting with the dot plot, the first thing I did was I recognized the smallest number I needed was 12, the biggest number I needed was 20, especially since it was a 20-point total exit ticket. So here, if I've separated them out, but they have roughly the same scale, that'll help me compare their shapes easier. So for Metro, I know that I have 12, I have 3 19s, a 20, and an 18. So it's fairly skewed to the right. Here, DU, meanwhile, had a 15, a 20, 2 16s, and an 18. So the centers of the data look already quite a bit different. So let's actually go ahead and start finding the means. Remember, for our means, the biggest thing I wanted to focus on was adding them up and then dividing by how many there were. So when I add up all of Metro's using my calculator, I end up with 107, and then there's 6 values. Or here, I have 105, and then there's 6 values. So if I do this, 107 divided by 6, it's going to land me at about 17.8. So I might round this to about 18. It's pretty close. So my mean's about 18. For DU, on the other hand, it's going to be about 7. It's going to be exactly 17.5, and so I can probably leave it right there. So now for the MAD, the mean absolute deviation. Remember here, we have to subtract to find the distance first. How far away is each point from the mean? Then we need to add them all up and divide by how many there are. So let's get organized first. So for Metro, we'll do here. DU will do right there. So for Metro, I've got 12, 19, 19, 19, 20, and 18. So knowing this, how far away is each of these? Metro is 18. How far away is each from 18? Well, I have 6. I have 1, 1, and 1, 2, and nothing. So how did I get those? I was subtracting them from 18 in my head. So I have 1, 2, 3, 4, 5, add 6, that's 11. Maybe add it a different way just to check. 6 plus 1 is 7, add 1 is 8, add 1 is 9, add 2 is 11. Gonna divide it by 6. That will give me my MAD here. Let's do DU while we're at it. So DU, we have 15, 20, 20, 18, 16, 16. This time we have a bit of a weird mean. It's 17.5. So here, 15 would be about 2.5 away. And then the other side, we're still 2.5 away. 2.5. 18, that's going to be 0.5. 1.5. And another 1.5. So I add all those up, all right? Let's see what I can do here. I know 2.5 and 2.5, that's 5. 2.5 and 0.5 is 3. 1.5 and 1.5 is 3. 3 and 3 is 6. And 5 and 6 is about 11. So I end up with 11 out of 6 no matter what. You divide 11 by 6. I think my mental math shouldn't do too bad here. I think it's going to be 1.8, but let's go ahead and check and see. So 11 divided by 6, 1.8 for both of them. So let's think about this. We've got our dot plot. We've got the mean. We've got the MAD. Now to think about the written analysis. You may need a separate sheet of paper, as I do here, to actually think about this written analysis. Some facts I might state. Well, here's what we know. We know that they have the same variability. The two classes have the same variability. So that's a first fact we can come up with. But look at their means. Their means are just slightly different, right? It looks like Metro maybe did a little bit better, and we can see that because they're closer to 18, whereas DU is more about just a little under 18. So here I might say the mean is slightly better for Metro than DU. And if you think about it, that makes sense because look, it's skewed right and skewed left. So then I could maybe say that too. Additionally, Additionally, the data for Metro is skewed right, while DU is slightly, not much, slightly skewed left. So all of this correcting can be going right on your exit ticket. So, which class do you think you'd rather be in? Well, I would think this one, right? It's more skewed towards the higher scores. This one's more skewed to the lower scores, and that affects the means just a little bit. We can see 18 is just a little better than 17.5. And the variability doesn't come into play because it's the same. So Metro did slightly better because their scores were skewed higher causing the typical score to be just a bit higher, just a little higher. So there's our assertion. And then we have, just all kinds of facts up here. So again, some of you might be sitting there thinking, well, I talked about variability, and the variability is the same, so I said you couldn't decide. Well, that's not true. Just because the variability is the same doesn't mean you can't pick one. It shows that our data is more skewed up than it is to down. Here, it's more skewed down. You'd rather have points pushing towards the 20 than pushing away from it. And the mean is also a little better. They're not quite the same, but they're also a little better. So here, variability was the same, so it didn't really help us decide. That's 1.8, not 18. So it doesn't really help us decide and think about which class is better. We have to use the means in this situation and the fact that one's skewed more left, so not as good. One's more skewed right, just a little bit better, but not much.